So let's look at a couple application problems here using exponentials and logarithms. So here we have, this is what we call an exponential growth function. And it looks like this. We have P, the population usually we're talking about, equals the initial population, P naught, or P sub 0, times e to the kt. Now this number e is the natural number e. It's not a variable. K is the growth rate as a decimal, and t is the time, which is our variable. So let's see how we can use this. The Oregon population in 2010 was 3.83 million. In 2018, it was 4.19 million. Okay, so we need to find the exponential growth rate percentage over the 8 years from 2010 to 2018. All right, so our initial amount, P naught, here is what we had at the beginning of 2010. That's 3.83 million. Okay, our growth rate, K, is something we don't know. All right, when T is 8, we know P of 8 is 4.19 million. Okay, and these are millions. All right, so we can fill in everything we know. Let's go ahead and fill in all of this. All right, we know that when T is 8, so we're going to put T equals to 8, and for T, we know P sub 0, the initial population. We know P of 8. The thing we don't know here is K. All right, 4.19 is our new population. The original population was 3.83. E to the K, which we don't know, times T, which is 8. Okay, and we could also write that as 8T, might work a little nicer there. E to the 8T. Remember, E is not a variable here. Okay, so we need to solve this here. So to do that, we need to get this exponential by itself. So first thing we've got to do is divide by 3.83. Now, that's just going to be a big, ugly decimal. So I like to keep that. Let's keep that as 4.19 over 3.83. We don't need to get an ugly decimal yet. Okay? So we've got this fraction, which also could be an ugly decimal. And this is now equal to the exponential. Well, we're ready to change it to a logarithm. We got to get this variable out there. All right? You know what? Actually, let me back up. I messed that up. All right? It's not ET, 8T. It's not ET either. ET is a movie, right? Okay. So it's 8K, and this is going to be e to the 8K. We're looking for K. 8 was the time. All right. So we're going to swing that base around, and we're going to have log base e, which is the natural log of 4.19 all over 3.83 equals 8K. And the last step is divide both sides by 8. And that's going to give us K is whatever the natural log of 4.19 all over 3.83 divided by 8. And now we can enter this whole thing carefully into our calculator. All right? So I'll let you go enter that in the calculator. Watch out for your divide. Make sure that this is all divided by 8. So make sure divided by 8 comes outside the parentheses. And that comes out to 0.01. Okay, actually 0.011 to be a little more accurate. So that is a 1.1% growth. Okay. All right. So that is a population growth rate, how that works. Okay. One more. Let's use our compound interest here formula. And we'll see here that, let's say we're going to put $20,000 in the bank. And we want it to grow to be $100,000. And we know we can have 9% interest rate, and we're compounding it monthly. That's important. Okay. All right, so what do we have? We know the initial amount, P, is $20,000. we want it to grow to $100,000. We know our rate is 0.09. Make sure you write that as a decimal. And it's being compound monthly, so n is 12. The thing we don't know is how long this is going to take. So we want to find the time. So let's substitute everything we know here. We've got, I missed a zero there, $100,000 is what we want, equals the principal, $20,000, times 1 plus the rate, 0.09, divided by 12, and all that to the 12t power. Just plug in all these variables into here, and the thing we don't know is t time. Okay, well, let's solve this up. The key is we want to get this whole thing by itself first. That's our exponential. So let's divide both sides by 20,000. And 100,000 divided by 20,000 is just 5. So 5 equals, and you know what, I'm going to go ahead and get this as a decimal, all right? And punching that in the calculator, that comes out to be 1.0075 to the 12t. That's a little easier to work with in that fraction. All right, we now have an exponential. So we want our next step, we want to get this 12t out of the exponent. So we're going to take that base, even though it's a weird base, we're going to swing it around here. And now we have log base 1.0075 of 5 equals 12t. Okay? And then last step we'll want is we'll divide that whole thing by 12. Okay, so let's go figure that out there. We have log base 5. Now actually let me back up here. Let's get this 12 out of here. So if we get this 12 out of here, okay, we need this as a decimal. Okay, so log base 1.0025. Get that back in there. Okay, so we're going to divide that. Actually, it's 0075, right? So let's get that in our calculator here. So we have, we've got to use a change of base here. So we're going to do the natural log of 5, close those parentheses, divided by the natural log of 1.0075. Okay, so natural log of, whoops, we're still back up here, natural log of 1.0075. Okay, so there's that number there. Okay, and we want to take that whole thing, and now we want to divide that by 12. So we take whatever that is and divide it by 12. So easy way to do this is to come back here. If you're using your graphing calculator, just hit enter and then use second answer. Okay, that's probably your easiest way there. But here, we'll put this whole thing in parentheses and we'll divide by 12. And there we have it. Okay, 17.95. All right, so T is about 17.95 years to make the money 5 times larger there. All right, if you get that 9% interest rate. All right, so that's the idea. That's how we do that. Okay, we take an exponential, change it into a logarithmic equation, and finish it off with our change of base as needed. Hope that helps. Keep at it, and thanks a lot.